So, how are you? Hope you're all well. Welcome to the class today for software quality assurance. It's been long since we talked with one another, issue with exams and everything, but I hope you guys are keeping well and keeping safe. Yesterday, there was a class for multimedia, and I think only one of you entered the class late, but the video is there, and I've also created a shareable link on YouTube, which you can, I know these videos will be deleted, but you just click on that link and you'll be able to get the class which we did yesterday. So today, welcome to this class, and we have been talking so far much about quality assurance. You have looked at what is quality assurance. We have looked at the role of quality in software development. You also looked at standards and the role of standards and procedures that are followed during quality assurance. And we have also looked at technical reviews and everything that has that's a quality assurance, then quality standards. And the last time we did, I think you guys did a cut, which I believe you have all been able to get the results of that cut. So today we are looking at testing and validation. I believe about the ISO 9000, 9001, ISO 9000. Okay, we shall just review a bit of those standards. But the foremost thing which I want us to be doing today and be looking at today is about testing. And this is in relation to software testing and its role in software quality assurance. The question we want to ask ourselves, does testing play a role in quality assurance? That's the main question we want to ask ourselves today. And first of all, we have to remind ourselves what is testing. So the way we shall recover this is by recapping software testing. And then we review if there is a role. We review if there is a role testing plays in quality assurance. So that is what we have to do first today. First of all, we have to recap. Then secondly, we have to review. We have to discuss, does testing play a role in quality assurance? So that's what we want to look at today, and it will be a very interesting aspect. One thing I would like to bring to attention is that one of the most overlooked phases in software development lifecycle, the software development project, is testing. Testing is one of the most overlooked processes in software development. When I mean by overlooked is that people do testing, but not up to the preferred level that testing should be done. And testing should be rigorous. Rigorous in the sense that you should put your software to all possible scenarios that may hamper the functioning of that software. Most of the time, most aspects of software which people most usually do is whereby they do the aspect called system testing. But there are so many various functions of testing, or various levels of testing, which need to be carried out so that we know that the software which you have developed is good and it can be able to handle any type of scenario that can be thrown at it. But that is one of the most underlooked processes in software development lifecycle. And it's underlooked because of various factors. One of the factors, maybe it's in timing, whereby, most of the software projects we have today, they are what we call rapid. They have rapid, what's the correct term? Rapid, not expansion, rapid. The time scale is so rapid that you're usually given a few months to develop a software that needs to be implemented. That's why we see that most of the methodologies we have, they're usually for the rapidness, like Agile, RAD, Rapid Application Development, like JAD. JAD is Joint Application Development, whereby you have various teams that are working on the same product. And when you're having various teams working on the same product, then it means that the time period needed to develop that software is usually halved. It's usually halved, meaning that if you look at the timeline for software development, I believe that a good software, if you're developing it, it should not go beyond 6 months. That is rapid. That is very rapid. So between six is the maximum. If anything goes beyond 6, then we are saying that now that one has gone to another level. But now when you come to software testing, you see, software development, you see that there's that aspect of rapid development, whereby you're given a few months to implement many aspects in a software, in which, in most cases, what most developers do, they do something we call code reuse. Code reuse, whereby you just reuse a code from a particular software which you saw, and you come and function it or modify it in such a way that it will work for the scenario in which you're doing. So one aspect which I'm usually seeing as a major as a major contributing factor to why people do not do testing is timing. The second major factor is cost. Testing costs. It costs people, it costs manpower, and it costs resources. So it costs manpower, time, and resources. So it's costing. And what do I mean by costing? Because you have to look for a third party. Test your software. Test the software. Most organizations, what they do, if they have in-house development teams, the in-house development team basically can be able to do a pilot run of the software on the users within that organization, so that they can be able to know if that software is working properly. So you see, cost. It can cost, because now these users are supposed to be doing their work. Now they have been taken from their normal job line to go and test a software, which after they have finished testing, it will depend on the recommendations of these particular users on whether or not to implement the software. So looking for a third party to test the software. So cost. So cost, it's another big issue which people never do. Another one is the procedure to follow and tools to use. There are tools which are used for testing, and one of the most sought after job nowadays in the job market for IT professionals is testing. If you have software testers, people who can come and test the software which you have developed. So we have, what procedure can we follow? What tools can we use to test our software? So the procedure is, there is a standardized procedure of how do we go about doing our testing. And that is where another big issue comes up, whereby many people do not follow up. They do not have a definite procedure. They do not have definite tools to use. Like, for example, you guys, you're now going to do your projects. You're supposed to do your projects. And in that project, not some, but all of you will have to come up with a test plan. And that test plan will tell us what components of the software did you test, what were the expected results, and what results did you get? And if they were countered with the expected results, how did you mitigate these aspects of whatever it is that you are testing? So it's a really key aspect in software development, which I usually find that sometimes people usually don't like doing the aspect that you have talked about. Now, we now come to the quality assurance phase. Quality assurance involves various aspects: plan, do, check, act. Yeah, I'll share you this HTML which I have here, but I'll share you. So we must have quality control and quality assurance. And I believe one aspect of quality control is used to ensure quality in a product or service. And I believe testing is one of the metrics, or is one of the tools that can be used to have quality control in a software. Okay. So quality control is not only about testing, but it also evaluates the people on their quality level skills and imparts training and certifications. So you must have software quality. So the first way in which you can ensure software quality is if you have the right personnel to develop that software, if you have the right personnel to test that software, if you have the right personnel to implement that software. So I believe testing is key and part of quality control. That is my view. Testing is key and part of quality control. Remember, we said quality control is there to ensure quality in a software, to ensure quality in a product. That's the major work of quality control. So testing is one way of whereby we ensure that quality is employed in a software. So for me, testing does play a role in quality assurance. Though most people will try and downplay it and say, no, but it does. And we shall be seeing how does it do it. So one thing we have to be assured of is that quality control becomes software testing. So what are the activities? So as I remember, I said that quality control, testing is a key part of quality control. And we basically know what quality control is. So quality control basically involves, quality control, if I write QC involves, QC involves walkthroughs. It also involves inspections, testing, and checkpoint review. So that is what quality involves. Quality control involves that. Quality involves walkthroughs, it involves inspections, it involves testing, it involves checkpoint review. And testing, as you can see, is an important aspect in quality control. So what is this testing? If I may share a PowerPoint slide that I had on testing, because we have to know what is testing, what it is that we're going to test, how are we going to test it, and the various aspects which you are going to look at when you're looking at testing. And as I say, testing is key part and parcel of software development life cycle. Okay. Now, as we look at that, talked about reviews, and reviews you have talked about, and you talked about project okay, it has opened. Usually used to lecture this so testing, overview of testing. So if I may just share. So you share. Now, testing, overview of testing, design test for high coverage, practical aspect of unit testing, integration and unit testing. So the first question is, do I need to test? That's the basic question each and every one of you will be asking themselves, especially when you're finalizing on your system projects. Do I need to test? That's unavoidable, okay? The only question is whether testing is conducted haphazardly, by random trial and error, or systematically with a plan. The goal is to try as many critical input combinations as possible given the time and resource constraint. Remember, I said that one factor which limits testing is time and resource constraint. So in my case, you can test using haphazard methods, you can test by random trial and error, or you can have a systematic plan. And this PowerPoint presentation says, why does it matter? But for me, I will come and tell you, my dear students, is that it is better to have a testing plan than to do aspects by trial and error. Because with the testing plan, one thing you have to know is that you cannot test everything. You cannot test everything. Can you do ethical hacking on your software? You cannot do ethical hacking on your software, because if it's a software that is to be deployed online, then you have to test its security aspect. Can someone be able to hack into the back end of my software and change anything that is in the back end of my software? And that is one area in testing whereby most developers don't do their tests unless it's a critical key software aspect or a software system that needs to be tested like that. So the key issue is strategies for identifying the highest priority tests. So which tests are of high priority? So that is the question which all of us will be asking ourselves when you develop a software, or even when you're developing an algorithm. For example, in our research work, I have to test my algorithm for various aspects, because if I'm developing an algorithm, then I have to test it for efficiency, for speed, for portability, for functionality. So those are the highest priority tests which I'm looking about. So testing shows the presence and not the absence of bugs. So testing shows the presence and not the absence of what? Bugs. So when you're testing, you're not actually trying to show that you have no faults, you have no bugs, but no, you're testing to show that there is a presence of bugs. A fault, also called defect or bug, is an erroneous hardware software element of a system that can cause system failure. So a test case, so we have test-driven development. Every step in the development process must start with a plan of how to verify that the result meets the goal. The developer should not create a software artifact unless they know how it will be what? Tested. Basically, a software artifact is basically in UML, a source code. So a software artifact should not create a software function which you know you will not test. Okay, so you must have test cases. So when you're doing those kinds of testing, you must have things you call test cases. And test cases basically is a choice of input data to be used in testing a program and the expected output or behavior. Now, when you're having a test case, basically that's what I was saying. I'll go back to the first statement which I came and say that it's really important. You must have we must have a plan. And the only way we can have a plan is if you have a test case. So test cases are really important when it comes to software development. And that's why we must have a particular choice of input data to be used in testing a program and the expected output or behavior. Sometimes if you're developing a software for an organization, you will basically use the live data. Okay, it's not as per se the live data, but you'll have to have a test case. You'll use data that is in relation to that organization so that you can test the functionality of your software with the user's data. So a test is basically made up of two types of tests. You have white box testing and black box testing. White box explores the structure within the program, and white box explores the structure, black box explores the input space of functionality, so defined by an interface specification. So those are the two types. You basically do both white box and black box testing. And these are some of the things which I will come and ask you in your project. How did you carry out your white box testing? How did you carry out your black box testing? So as a software developer, as an IT student, it is your work now to go and sit down and say, how do I carry out white box testing? How do I carry out black box testing? And now the funny thing with this thing, you see, these are all an aspect of quality control. If I'm exploiting the structure, then I'm trying to see how is the program code? How was this program coded? Did it follow the necessary standards for program development? If I'm testing the input space of functionality, I look at the interface specification. If it's supposed to do a certain functionality, does it do the correct functionality? Okay. Why is testing hard? Okay. Any non-trivial system cannot be completely. That's what even I said a few minutes earlier. You cannot test everything. So our goal is to find faults as cheaply and quickly as possible. Ideal, design a single write test case to expose each fault and run it. So that's the main thing. If you decided to test your whole system as a whole, then it would be timely and it would be expensive. So you cannot do that. So in practice, you have to run many unsuccessful test cases that not expose what? Any tests, any faults. That is how we usually do our tests. I'll come and ask you for test case. You'll come and tell me, for example, this is the most common test case I've ever seen, whereby students just go, you carry a test case of the authentication. Here I have my login box. I enter this password, it logs in. I enter the wrong credentials, it does not log in. I have passed the test for authentication. But remember, there are so many things in relation to authentication you have not tested. You have not tested the aspect of hacking. You cannot test hacking on your software at that moment because it will need you to bring other aspects which you do not have time and even money to do. So that is what we have here in saying in practice, we have to run many unsuccessful test cases that do not expose any faults. Unsuccessful. That's the thing we have to look for. Because with that test of yours, to you, it is successful because it has either logged in or not logged in. But remember, there's so many other scenarios which are in relation to that test case, which you should have done. The underlying, a key trade-off of testing is that testing as many potential cases as possible, high degree of test while keeping the common cost limited. That's true. If you do a lot of testing aspects on your software, then the cost will go high. That's what I say. So the underlying software testing is correcting behavior on critical test, is representative of correcting behavior on untested parts of the state space. So what you do, what I would easily advise students is when you're developing a software, you look at critical areas you would like to test. And the critical areas, one of them is security. That is very good, right? That's why most people do their fast testing. The second test case scenario is whereby you test whether this software does its correct functionality. And the third one is the output, the interface. That is how you do it. And the fourth one is it's in relation to the environment around that software testing. So we usually have those aspects which you have, which you need to be carrying out most of it. Okay. Now, so that's testing is hard. So we have to test our software on limited case scenarios. And from those limited case scenarios, you can try and generalize them to the whole software so that we can say, if these case scenarios have an issue, then it means that the general software also has an issue. Sampling, that's why you learn sampling. You test a sample. You have a sample size. You have a sample of your software you test. And from that sample, you generalize it to the whole software. So local organization of testing, and here there's a disclaimer, usually not done in linear step by order, and commuter in the last step is usually reached out. So here we have the normal testing which you have, the unit testing, unit code, and then you have integration testing. So ensures that all components work together. So basically the most basic element you have in your software is a unit. Component unit of code. So unit of code is basically like a line of code. Lines of code, lines of code, lines of code, lines of code. And then you have to do integration testing. Do these lines of code all achieve functionality? Do they do the right thing? So all components work together. And then you have system tests. So the integrated modules. So meaning that each of these lines of code, they formulate part of a module. And many modules, when you combine them together, formulate part of a system. So whiteboard testing, as you can see, is done by the developer. So whiteboard testing here, you said you test the input space. You test the input space. So the input space is actually the code which you've actually written. So here we have the types of tests which you can carry out in system testing. You have function test. So you verify the functional requirements are satisfied, and then you have quality tests. Verifying non-functional requirements are satisfied. Remember, we had those aspects of functional and non-functional requirements. So remember function testing. We have various types of functional requirements. And remember, when you get these requirements are gotten, these requirements are what you transpired after you had gathered all the user what requirements. So you remember in the software development lifecycle, you did requirements capturing, requirements gathering, and requirements analysis. Then you come and you integrate them and you create functional requirements and non-functional requirements. So functional requirements is basically what the software is doing, and non-functional requirements, these are now aspects you test. Non-functional requirement, quality attributes you test. Remember the attributes which you are talking about: portability, security, efficiency. Remember when I asked you in the first lesson, what are some? Remember when you were saying what are the attributes of a good software, and you are able to tell me, oh, security, it's portable, it's maintainable, it is efficient, it is flexible. Now, when you're carrying out that type of test, you're actually carrying out quality testing, and you see functional testing ultimately leads to quality testing. If your function is able to do its correct work and it does its correct work at the required amount of time using less required resources and everything, then it is able to do what we call quality testing. So just have a few seconds. You look at that model, and let me just check up on something here. I want to check up on something. You see. So as you can see, that aspect. Then you have done white box testing by the developer, and then the customer comes now and does black box testing. You test the functional, the structure of the system. So here you do acceptance testing. So the customer verifies all requirements are done, and then testing in user environment platform. So system use. So first of all, you have to test your software in your lab, and then you go and test it in the user's environment. That's where there's that whole debacle. And that's why we are saying that you need to do this kind of test. So this is the logical organization of testing. It's not done in that linear kind of a scenario. Now, acceptance testing. Talking about acceptance testing. Safe home access examples. Focuses on the external behavior. Test with the valid key of a current tenant or his apartment, pass expected results. So this is an example of how you carry out acceptance testing. So what most of you guys, when you're telling us that, now, here's the thing, for your projects, I believe for your projects, you can create data that mimics the organization with which you've developed that software for. So if it's real information, kindly create data set of real information of these people. Do not go and put X, X, Y, Z, V, 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 T, D. No, create real names, real people, real names, real addresses of these people, so that when you're doing that acceptance testing, when you're trying to depict to us, because you'll depict to us functional testing and you'll depict to us acceptance testing and also installation testing. Now, here's the funny bit. Although I've seen it in ZTech, but I remember when in JQuat, when I was doing our degree, when you are doing our degree, and we are doing our projects, the first requirement was that you should install your software in the lab's computers. Once that software is installed in the lab computers, or you can be able to run it on the lab computers, then you have passed the installation The installation test. Now, what I see most of the time here is that you come with your own laptop. Come with your own laptop. Okay. Coding. So, as I was saying, when the user now carries out that, I was giving an example when we are doing our degree, we had to install it first in the labs. So if your software installed in the labs, then you pass the installation test. If it didn't, then you had failed the installation test because you're developing a software to work with the user's environment. And I was giving an example of these types of tests which you carry out as the input data. So example of a test for use case. So you have test case identifier. This is the test case 1, use case identifier, main success scenario, use case 7, pass or fail. The test pass if the user enters a key that is contained in the database with less than the maximum allowed number of unsuccessful attempts. Input data, numeric key code, do identify. Step 1, type in an incorrect key code and a valid do identify. So here you're trying to check if I input an incorrect key code, what are the expected result? Type 2, type in the correct, and so what will be expected? So here, this is how you carry out a test case for use case. So use case is user enters a key that is contained in the database with less than a maximum number allowed of unsuccessful attempts. Let's say you're trying to log in. So you create a test procedure in the expected result. So test coverage. Now we have looked at the use case and you have looked at the logical organization of testing, an example of a test use case. Now test coverage measures the degree to which the specification of code or a software has been exercised by test. So how big in your software, how big has it cost? So big picture specification testing focuses on coverage of the input test, while code average measures the degree to which the element of the program source code have been tested. So acceptance testing and unit test. So input space, that is done by the user, and unit test is done by you. So some tests are more critical than others. Test case should be prioritized. Some tests are more likely to uncover faults. People are prone to make certain kind of errors. Some tests can easily pinpoint problems than others. So this is how you're able to achieve high coverage when you have things like equivalence and boundary control for state-based testing. So we have equivalence testing. It's a black box method that divides the space of all possible inputs into equivalence groups, such that the group is supposed to behave in the same on each input from the same group. So partition the values of input parameters and all of that. There's something here that is going on. Okay. Okay, just a bit. Let me just pause here. Sorry about that, about the issue of just that there was some problem here which needed to be sorted. I hope they'll be sorted. So equivalence testing, boundary testing, control for state-based testing, all these are some of the examples of test case which you could carry out on your software. And you say that testing is a key component used in software quality assurance. Now, what is the difference between software quality assurance and software testing? What is the difference between these two? Now, if I may be able to share this screen of mine. So difference between software quality assurance and software testing. So SQA is about engineering process that ensures quality. Software testing is to test a product for problems before the product goes live. SQA implements activities related to implementation process, procedures, and standards. Example, audit training. Testing involves active concerning verification, activities concerning verification of the product, example, review testing. SQA is product process focused, while testing is product focused. SQA is preventive, testing is corrective. SQA is proactive, and software testing is reactive. SQA is applied to all products that were created by the organization, while testing, scope of testing applies to a particular product being tested. So, as you can see that if an organization involves various aspects, then it means that that kind of testing that shall occur there, you shall have to incorporate both aspects of quality assurance and quality testing. And we've seen that testing is a key component of quality assurance. Thus, it is really important to get that aspect of aspects like that and be able to get those various aspects. Now, that's the scope of testing. So we have looked at various quality assurance functionality and the CMI level and the initial testing and the testing maturity level. So here's one thing I would like to talk about, the testing maturity level. This model assesses the maturity of processes in a testing environment. It has 5 levels. It has the initial. There's no quality standard followed for testing process, and only ad hoc methods are used in this level. We have definition, where we have defined processes. We have integration. Testing is carried out throughout the software development lifecycle, which is nothing but integration with the different development activities. And then management and measurement, and then optimization, which preventive techniques are used for testing processes and tools, automations, and all of that. So basically, we have seen that testing is an important aspect in software development, and thus it is really key. And you have seen that it's really key when it comes to software development and software testing and everything. Now, what is the difference between validation and verification? Now, verification, when you're doing verification, you're actually verifying that the components that were needed to be installed are correctly installed within the software, while validation is that you're validating that the process that you followed was correct and through the point. And that's why in software we have both verification and validation. That's the whole reasoning for that aspect. And so it's really important that we follow the correct procedure in everything that we do, so that we do not have aspects that might lead to issues when you're looking at software quality assurance. And software quality assurance is really important, as you have been able to see. So we would go through this as we would provide this handout, and you'll be able to look at it and be able to know in depthly what those aspects are all about. Now, let's talk about software standards, software development standards. And because we are talking about the ISO 9000, ISO 9001, ISO 9002. So standards basically are documented agreement containing technical specification and other precise criteria to be used consistently as rules, guidelines, or definition of characteristics to ensure that materials, products, process, and service are fit for the purpose. So that's what standard is. If you are to look for a definition, definition of what a standard is all about. So that's what a standard is. Standards are documented agreements containing technical specification or other precise criteria to be used consistently as rules, guidelines, or definitions of characteristics to ensure that materials, product, processes, and services are fit for their purpose. That is according to ISO 1997. That's how they define software standards. Now, we have various types of software standards. I don't know if I'll be able to get them here. And they are documented procedures. They are de facto. So there are procedures that must be followed. So why adopt a standard? Why adopt a standard? Why adopt a standard? So why adopt a standard? So why do we need to adopt a standard? So the first reason why you adopt a standard is as a means of transferring good practice in software engineering. That's why the first reason. It's a means of transferring good practice in software engineering. Secondly, is as a safety net. Safety net. Thirdly, it's for product certification. So as a means of transferring practice software engineering, as a safety net, and for product certification, which ultimately means if you have a product if you have your product certified, then it means that you will have a wider reach. It can translate to wider reach of consumers of your product. That's why it is highly important that we have to do that. So standards are really important. So we have various standardized processes. We have the ISO, and we have the International Standards Organization, and you have the International Electric Commission, IEC. Okay, so there are various documents. We have international standards and the technical reports, which I'll share these materials, and then we have the processes and everything that are in relation to those standards. My main aspect was on types of standards that can be talked about, such software quality assurance. I don't have that handout. Was that there's a usually had, which contained those aspects of standards that I will share. Okay, no problem. So standards are really important, and key example of standards are there are so many which I will be able to verify and share with you this handout. But the most important one is the ISO 9001. We had 2008, now we have 2015 standard. And this 2015 standard is very important, and it's very helpful when it comes to these aspects, which really help in us settling these things. So it's really important that when you're looking at standards, that we talk about various aspects of the standard, so that you can be able to analyze and know that these aspects are what have been used, and they're really important when it comes to software development process. So I will share these materials with you people, and at the end of it all, I believe that you can come up with me the test case so that you can be able to look at this thing. So I'm currently looking for some work for you guys to do. ISO 9001 2015. Software development. So the ISO standard for software development is the ISO IEC 9003 Software Engineering Guidelines for Application to Software. So this is the software standard. So the ISO guidelines, the ISO IEC 9003 Software Engineering Guidelines for Application of ISO 9001 2015 to computer software, is designed as a checklist for the development, supply, and maintenance of computer software. So the main work now, there's the main work which I would like you guys to go and do. And this one shall be in relation to the work that I will I'll give to you, and the use of ISO 9001 with software development, and interpreting the requirements in ISO 9001 for software development, and review. So my work for you guys would be to review these two websites which I have. These two, that's the first website I would like you to look at. And then the second one is this one. So actually this should be the first, and then the other one should be the second. So I'd like you to review those two. I'd like you to review those two websites and compile comprehensive paper on the on how ISO 9000 standard, not even 9001, 9001. It's actually 9001. ISO 9001 standard. ISO 9001 standard has brought to the fore how ISO 9001 standard has brought to the fore. I mean, when I say something has been brought, it has been brought to the foreground, has brought to the fore the importance of enhancing and ensuring quality of software. Enhancing and ensuring quality of software. So that's what I want to do. So you read this too, and you compile for me a paper, and that paper should be bringing about how this standard has enhanced and ensured quality of the softwares that are being developed nowadays. So that is the work which I would like you guys to look at, and it also be in terms of an assignment which I will share with you on the course website, because that's what is most important. I'll share with you on the course website so that you may be able to do that work, and we may be at par. So kindly be on the lookout for the video. It will be there and you shall be able to do it. So for now, thank you, and that's what we do. Now, the next one, we shall be looking at software metrics, which shall be in the course of next week. So thank you.